Hello students, welcome back to the channel. Today we are going to master mole concept in just 10 minutes. Let's solve some important MCQs that are frequently asked in the exams. Before solving the questions, let us see some important formulas. So the first formula is number of moles. It is mass upon molar mass. 1 mole is the amount of substance that contain 6.022 into 10 raised to 23 particles, entities such as atom, molecule or ion. The number 6.022 into 10 raised to 23 is known as Avogadro's number. Similarly, from Avogadro's law, 1 mole of any gas occupies a volume of 22.4 dm³ at standard temperature and pressure. And hence number of moles formula for gas will become the ratio of volume of the gas at STP to the molar volume of the gas. The molar volume of the gas that has recently changed by IUPAC, that is 22.71 liter per mole, and the condition of standard pressure become 1 bar. Now we will move to the next formula, and that is molarity. It is the number of moles of solute to the volume of solution in liters. The unit for molarity is mole per liter. Last but not the least, we'll see the empirical formula of compound. The empirical formula of a compound is the simplest whole number ratio of atom of each element present in the compound. It does not give the actual number of atom, it only gives simplest ratio. To calculate empirical formula, you need to follow the following steps. 1. Write percentage composition of each element. Second step, convert percentage to gram by assuming 100 gram of sample. Next, divide each by atomic mass to get their number of moles. Divide all mole values by smallest whole value. Make whole number if multiplication is needed. Now let's begin with problem solving. First problem is how many moles are present in 22 gram of carbon dioxide, and the options are: to solve this problem, in the first step write the number of moles formula. Also, mass of a carbon dioxide is given. We need to calculate molar mass of carbon dioxide, and that is 44 gram per mole. Substitute all these values onto the moles formula to get the 0.5 mole. So the correct answer is 0.5. Second question is similar to the first one, that is how many moles are present in 18 gram of water. Similarly, to calculate this with the help of formula, you need to calculate molar mass of water, that is 18 gram per mole. Substitute mass and molar mass value to get the moles of water, and that is 1 mole. Move to the next. The volume occupied by 1 mole of any gas at STP is, as we know, 1 mole of gas at standard temperature and pressure is 22.4 liter. Next is the value of Avogadro's number is, as we know, it is 6.022 into 10 raised to 23 particles. Question number 3 and 4 are conceptual questions. Move to the next question, and that is the unit of molarity is. As we know from the formula, molarity is number of moles of solute to the volume of solution in liter. So the molarity become mole per liter. Now we will talk about other options. Mole per kg goes to molality, gram per liter is concentration, and equivalence per liter represent normality. Next is the empirical formula of C2H4O2 is. To calculate this, step 1, write the ratio of each element, that is carbon, hydrogen and oxygen. In this step 2, divide by the smallest number, that is 2. It will become 1:2:1, and based on that, in the step 3, write the formula, and that is CH2O. Move to the next question, that is the percentage of oxygen in water is. To solve this type of question, you need to know the percentage of atom formula, and that is atomic weight of the element divided by molar mass of compound multiplied by 100. As we know, mass of oxygen is 16 and molar mass is 18 gram per mole. So the percentage of oxygen in water will become 88.9%. Now the next question will be based on number of moles, that is how many moles are present in 32 gram of oxygen. As we know from the moles formula, mass of oxygen is equals to 32 gram. Also molar mass of oxygen is 32 gram per mole. While substituting all these values, we'll get 1 mole. Moving to the next question, that is 0.5 mole of sodium chloride contain how many formula units? From the concept we know 1 mole of any substance equals to 6.022 into 10 raised to 23 particles. So number of units is equals to mole into Avogadro number. While substituting the value, we'll get 3.01 into 10 raised to 23 units. Moving to the next, the number of atoms present in 4.4 gram of carbon dioxide. As we know mass and molar mass of carbon dioxide, so first we need to calculate number of moles. Substitute the values to get 0.1 mole. In the second step, calculate number of molecules using Avogadro number. It will become 6.022 into 10 raised to 22 molecule. And since one molecule contains 3 atoms of carbon dioxide, so 6.022 into 10 raised to 22 molecule will contain 1.806 into 10 raised to 23 atoms. Moving to the next type of MCQs is 5.6 liter of oxygen at STP reacts completely with hydrogen. The mass of hydrogen required is. To calculate this, the first you need to write the balance chemical reaction. After that, calculate number of moles based on that reaction, and it will give you 0.25 mole. Now using stoichiometry, we know 1 mole of oxygen is equals to 2 mole of hydrogen. Therefore, 0.2 mole of oxygen will be equals to 0.5 moles of hydrogen. And when we multiply moles into molar mass, we'll get actual mass required for the reaction. Move to the next question. The number of electrons present in 1 mole of sodium ion is. As we know, sodium ion loses 1 electrons and it will total have 10 electrons. For 1 mole, number of electrons multiplied by Avogadro number will give total number of ion present, and that is 6.022 into 10 raised to 24 of sodium ions. Moving to the next question, that is 3 gram of hydrogen and 28 gram of nitrogen react to form ammonia. The limiting reagent is. To solve this type of MCQs, first you need to write balance chemical reaction, and after that calculate number of moles for nitrogen and hydrogen respectively. After that, check the ratio. As we know 1 mole of nitrogen needs 3 mole of hydrogen, but we have only 1.5 mole of hydrogen. Therefore, hydrogen is insufficient, and that goes to limiting reagent in the above reaction. Moving to the next question, a compound contains 40% of carbon, 6.67% of hydrogen and 53.33% of oxygen. Its empirical formula is. So, by assuming 100 gram of compound, you need to calculate ratio of respective elements. After that, divide by the smallest number, that is 3.33, so you will get simplest ratio number, and based on that you can write empirical formula. Now moving to the last question, that is 0.5 mole of solution is diluted to 1 liter. If initial volume was 200 ml, the initial molarity was. So, based on the given in the numerical and from the dilution formula, that is M1V1 is equals to M2V2, rearrange and substitute the value to calculate initial molarity of the solution, and that is 2.5 molar. Students, now it's your turn. Challenge for you. Solve the given numerical and comment your answer below. Let's see who get it right. Thank you for watching and stay tuned for more videos like this.